Okay, for this problem, you're asked to determine the region created by those three graphs and revolve it about the line y equals 1 using either the disk or the washer method to find the volume of the solid generated. Okay, so here's a picture of the graph of x equals y cubed, which can also be written this way: y equals x to the 1/3. And that's something that you have to be able to do to use both methods to solve for y in terms of x. And this is the region that we want to revolve about the line y equals 1, that green line. Okay, so here on board 3, I've shown the setup of the integrals. This is the integral that you would use for the shell method. And this is the integral that you would use for the washer method. And here's the exact answer right here, pi over 10. And that matches these decimal approximations. So the question is, how do you set up this integral? Well, if you're going to use the shell method, your shells you want to be parallel to the axis of revolution. So here I've drawn one typical shell, and then the formula you use to find the volume of revolution is 2 pi times the integral from, in this case, 0 to 1. We're creating these shells from this 0, here's another shell, up to 1. Well, that 1 is this y value right here. We're integrating along the y-axis. And then what we put as the integrand is the average radius. That's the distance from the axis of revolution to what we say is the center of the shell, where this is some typical y value between the interval from 0 to 1. Well, the length of that average radius is the y coordinate at the top minus the y coordinate at the bottom. So it's 1 minus y. That's the average radius right here. And then multiply that times the height of the shell. Well, that's this distance right here. And that's an x distance. And that distance is x equals y cubed. And then dy, we say, is the thickness of the shell. Of course, if you distribute the y to the third power over this 1 minus y, it's easy to find the antiderivative and find this exact value. I won't go through that. And here we'll use the washer method, which we want our typical washer to be perpendicular to the axis of revolution. And the formula is pi times, in this case, we're integrating along the x-axis from 0 to 1. So that 1 is that 1 right there. And we want to say, now, if we're actually using the disk method, because there's no, quote, hole between the axis of revolution and the curve. So we're using the disk method. If we were using the washer method, it would be the outer radius squared minus the inner radius squared. But this distance right here is the radius. And that's 1 minus that y value. And that y value depends on x. So for each x in here, this distance right here is x to the 1/3 power. That's what you do to x to get the y coordinate of points on the curve. And so this distance, the radius, is 1. Take away the y coordinate at the bottom. 1 minus x to the 1/3. You got to square that, radius squared. And if you wanted to do this method, you'd have to square that binomial. take the antiderivative term by term, and you'd still get the same answer that you got with the shell method. There you go. Hope that helped. If you have any questions, post a comment.